Now we move towards the next part of this one, that is checkpoint. So in the previous immediate and deferred database modification, in immediate what we have seen that every time we check whether the transaction is committed or not. If it is committed, then it performs the redo operation. If it is not committed, then it performs the undo operation. Now see here, for example, if there are hundreds of transactions are executed serially. Okay, hundreds of transactions are executed serially in the system. And if a failure occurs in transaction number T67, if a failure occurs in transaction T67, then what we need to do? We need to check all the transactions before it, T1 to T67. If the transaction TI start and TI commit is there, then we need to perform redo. If only TI start is there and then no TI commit, then we need to perform undo. See once again, if there are hundreds of transactions are executed serially one after another in the system, and after or during the transaction T67, if a failure occurs, then what we need to do? We need to check all the transactions before it, T1 to T67, and the transaction for which there is both TI start and TI commit, we need to do redo, and the transaction for which there is only TI start and no TI commit, we need to do undo. Is it clear? Means how much time consuming it is. Correct? 67. Suppose there are thousands of transactions and at the transaction T700 if a failure occur, then previous all 700 transactions we need to redo and undo. And doing this redo, not necessary. Why? Because the transaction is already committed. All the values are already stored on the disk or updated on the disk. Then performing this redo is time consuming and there is no reason to perform this all redo operation if the transaction is already committed. Is it clear to you what is the problem there? Yes or no? Is it clear what problem occurs if we perform all this transaction redo and undo operation? Then only you will understood the checkpoint concept. So here doing all this redo and undo operation for all the previous transaction which is already committed, to avoid this, the concept of checkpoint is used in log-based recovery. Now see what is checkpoint. Redoing and undoing of all transactions recorded in the log can be very slow. Processing the entire log is time consuming. If a transaction has hundreds of instructions, then we need to redo all these data items. If it is using 10, 20 data items, we need to update all that 20 data items. So processing the entire log is time consuming if the system runs for a long time. So we might unnecessarily redo transactions which have already output their update to the database. So in that case, if a transaction a failure occurs in T67 and already T50 transactions are already completed, then in that case, it is not necessary to redo that 50 transactions. Whatever the transactions are still active, we need to perform only the redo and undo operation for that transaction. If the transaction already completed, not necessary to do the redo operation. So how to avoid it? For that, the procedure used by log-based recovery is performing checkpoint. Now what is checkpoint here or how it performs? Output all log records currently residing in main memory to the stable storage. Whatever the log records are there, first output all these log records to the stable storage. Now for example, if we consider there are T1 transaction with some T1 start, T1 something, and then T1 commit. Then there is T2 start, some modification of T2 commit. Okay, there is T3 start, doing his modification, etc. So output all log records currently residing in main memory to the stable storage. So how to perform the checkpoint? These all log records, whatever created, these are first output to the stable storage. Okay, whatever the log generated. Next, output all modified buffer blocks to the disk. Where all these modification? These are done on the buffer blocks. Then output that buffer blocks onto the disk. Transfer this onto the disk, whatever the outputs are made. Then write a log record checkpoint. So after this, write a log record checkpoint here somewhere. Periodically it is generated. Okay, after some time the checkpoint is automatically generated. So write a log record checkpoint L onto the stable storage where L is the list of transactions active at that time of checkpoint. So during this, suppose here T4 started, T5 started, and then the checkpoint is generated. So what is this L? It is the list of transactions which are still active. So here 3 transactions are still active. These are already committed, T1 and T2. But T3, T4 and T5 all active transactions. So L is the list of all transactions which are active at the time of checkpoint. All updates are stopped while doing the checkpoint. Means no other transaction can update any data item while doing the checkpoint. So after a failure occurs, the system examines the log, find the last checkpoint. Where is the last checkpoint from the backward? This can be done by searching the log records backward from the end of the log. Means here, for example, suppose T3 start is there, some operation it is doing. In between T4 start is there, it is doing some operation, and then here the checkpoint is generated. Okay, so in that case start from the backward, and after that suppose there is T5 start, there is performing some operation, T6 start performing some operation, in between T5 is committed, then in between T4 is committed. So at this time, if a failure occurs here, then what it perform? Start from the backward of the log until the first checkpoint record is found. So here we got a first checkpoint. The redo and undo operation need to be applied only to the transaction L. So in L now what are the transactions which are active at this point? Which are active? T3, T4, T5 and T6. All are active. So the redo and undo operation need to be applied to only transactions in L. The L, what it include? All the active transactions. Now see here with example. So imagine this example. Here we consider that there are 4 transactions are executing T1, T2, T3 and T4. Here is the checkpoint which is inserted. So what is the list L here? In this check list, all the transactions which are active. So whether it is active, T1 already completed. So in the list it is T2, T3, T4. 3 transactions are there. If a failure occurs here, then start backward. Find out the first checkpoint where it is here. Now during this check the list L, the transactions which are active. See once again, the transaction T1, T2, T3, T4 are performing serially one after another. If a failure occurs, then it goes backward until the first checkpoint. We get the first checkpoint. What is the list of active transaction? T2, T3 and T4. Now in this case, simply for all these active transaction, if TI start and TI commit is there, then we need to perform redo. And if only TI start is there, no TI commit, we need to perform undo. Now in this case, it start from checkpoint backward, go here, it is the first checkpoint. In the list there are 3 transactions. Now what is T2? TI start is there, TI commit is there, both are there. T2 start is there and T2 commit is also there. Okay, so what we need to do here? We need to do redo T2. We need to do redo T2. Why? Because both are there. T0 start and T0 commit, or T2 start and T2 commit is there. Now regarding T3, T1 is ignored. Why? Because it is not active. Now T3. T3 start is there and T3 commit is there. So here we need to do redo T3. Now what about the T4? T4 start is there but not commit is there. Regarding T4, T4 start is there but not T4 commit. So we need to do undo for T4. Is it clear to everyone? So in our case, the example that I told, that if transaction T67, if a failure occurs and the checkpoint is in transaction T50, or in after the transaction T50, whatever, all are in the active list. All are in active list. Then the previous T1 to T49 are totally ignored. Not necessary to do redo and undo. And it's a very, or it saves time for us. And the cost also. See once again, if there are hundreds of transactions and if a failure occurs in T67, then it goes backward from T67 until it got the first checkpoint. If the first checkpoint is in transaction T50, it is in transaction T50. So in that case, the previous T1 to T49 all are ignored and only T50 to T67 are considered. And the transaction for which there is both start and commit, then it perform redo, and for which there is only start, it perform undo. So that is the simple concept of checkpoint.